All right, so these are the notes. Here's just a picture of what I just talked about in the previous video. Now let's talk about some definitions and go back, so on and so forth. So a median is a line segment that joins a vertex to the midpoint of the opposite side. So above, like, oops, I thought it was in highlighter, but BF, AD, and EC are medians. So we'll kind of make an arrow up there. All right, and examples were BF was a median, because this is a midpoint, AD, because that was a midpoint, and then EC, because that was a midpoint. All right, those are the medians. The three medians of a triangle intersect at one point, just like the perpendicular bisectors and angle bisectors. So remember, perpendicular bisector, that makes the circumcenter. This angle bisectors, that was called the end center. And this is the third and final center we're going to talk about. They all intersect at a single point. We call this the centroid, which is actually just the balancing point. So it's where you balance the triangle. Or you might hear it called the center of mass. And above this is point P. And they like to call it the centroid point P. Why? I'm not really sure, but just whenever you see P, that means centroid for reasons. All right, so this is going to be an intense page right here, a lot of coordinate geometry. But again, when we do coordinate geometry, we're reviewing so much from this year and preparing ourselves for stuff we're going to need in Algebra 2. So this is great stuff we're doing. So we're going to find the centroid, the center of gravity for the given triangle. All right. So we're going to do coordinate geometry. This is very lengthy, but then tomorrow we're going to have an algebra shortcut, which is super easy. But again, learning the long, tedious way really practices some basic skills that we really need to have a lot of success in this class. So let me think about what I want to do. Let's go ahead and find the midpoint of each side first. All right. So we found the midpoint right here, because AC, this is a length of 6. So I'm going to call that lowercase b. All right, then this side again, we can always just kind of count and guesstimate the midpoint. Or not guesstimate, but count to find the midpoint without using the formula. So since I went up 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I went up 6 over 12. Again, the midpoint cuts it in half. So from point B, I'm just going to go up 3 over 6. And boom, ends up right there. And then this last side, BA, again, a lot of counting going on. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Up 12 over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So up 12 over 12, I'm just going to go up 6. 1, 2, 3, 4, 5, 6 over 6. So we need to know our formulas, our midpoint formula. But sometimes we can just kind of cheat, not cheat, but just simplify things and count. All right, and I was doing that wrong line. I drew a mid-segment on accident. So remember, we are going to connect the angle, the vertex, to opposite midpoint. So that right there, that's a median. All right, vertex of an angle. So from the angle to the opposite midpoint. That's another median, and here's the last median. And good, they all intersected at a single point, and we'll call that point P. And it appears that point P is just at 1, 1. All right. So if I took my iPad, cut this triangle out, well, not only would I destroy my iPad, but I would be able to take this triangle, hold it in my hands, and that would be the balancing point right there, 1, 1. All right. So that's the balancing point if this triangle was outside of my iPad, the center of mass. So We just counted the midpoints, created medians, all in coordinate geometry, great. So what is the distance from C to the centroid? So basically this is saying what's the distance from C to P, the centroid. And we can just go ahead and count 1, 2, 3, 4. CP equals 4. All right, and then lowercase c, uppercase, oops, sorry. What is the distance from the centroid to the midpoint on segment AB? Well, it's lowercase c, uppercase P, because now we're finding this distance right here. So we found that this length of 4 over here. Now we're finding this length 2. All right. What did we notice? Centroid to, we're just oversimplifying right now. There's a billion ways we could phrase this. Centroid to midpoint, which was lowercase c, uppercase B, is half the length of centroid to vertex, which is uppercase C, uppercase P. All right, so that's what we noticed. And again, 4, 2, it was half the length. All right. So now we're going to do a similar thing. We're not going to do this for all sides because time is of the essence. But what is the distance from A to the centroid? So we're finding this length right here now. A to the centroid. Well, let's use Pythagorean theorem shortcut and set up a right triangle. And what do we got going on here? This is a length of 1, 2, 3, 4, 5, 6. That is 1, 2, 3, 4. All right, and I'm going to call that x. The length we're looking for, I'm going to call x. So x squared equals 6 squared plus 4 squared. X squared equals 36 plus 16. X squared equals 52. So x equals the square root of 52. Which, let me get my handy calculator. Where's my calculator? Lost it. We'll just keep it. We'll write 7.1-ish. Or we'll say about 7.2. How about that? All right. Don't know where I put my calculator. I gotta find that. Anyways. And then we're gonna do from the centroid to midpoint BC. So again, now we're just gonna do this, which is about that, 3, 2. This time I'll call it y. We gotta call it something different, but just using Pythagorean theorem shortcut, we got y squared equals 3 squared plus 2 squared. Y squared equals 9 plus 4. Y squared equals 13. Y equals the square root of 13, which is about 3.6. So again, it's half. Instead of rewriting that all again, we're just going to say it's about half. Or no, it's exactly half. All right. So we got all these intense relationships going on here. All right. This is what we wanted to kind of emphasize. Especially this is kind of nice and clear to see 4 and 2 or 7.2 and 3.6. All right. But with the centroid and the lengths of the medians, these ratios are always true. All right. So let's just focus on certain stuff at a time. AP is 2/3 of the length of AL. So hold on. A is supposed to be up here. So what's really saying is just let's call this, let me think. We'll use those numbers we had above, 4 and 2. So if we can put this into, let me think. Let's say it like this. AL is 6. All right, so since AL is 6, AP is 4. So I'm just using similar numbers to as above, 2. All right. So this first one is saying, well, AP is 2/3 the length of AL, which is true because AP, well, AL is 6. 2/3 of 6 is 4. All right, so that's why that one works. You can also say that you can also say that AP equals 2 times PL. All right, it's double the distance of the shorter side, which makes sense plugging in the numbers. PL was 2, AP is still 4. All right, so these are just some ratios, very intense, and we're going to go through these one by one. In fact, here's the last one. PL, you can say is 1/3 the length. Let me write it down here. You can say PL is 1/3 the length of AL, which is true because AL was 6, which makes that 2. All right, so there's intense ratios that tell you the length of specific parts of the segment, of the centroid, of the balancing point. Sounds difficult, but we're going to practice these all in depth and get really good at them in the next video.